This is chapter 8. I'm Florencia. Hello. In this video, we will estimate the weighted average cost of capital for a company that is not listed in the stock market. Therefore, we do not have historical prices. This could be a startup or it could be a family enterprise. And as we do not have historical prices, the first calculation, which is the risk of the company, will be using the comparable approach for beta, which is basically to copy the risk or use the risk of a similar company in terms of systematic risks, making an adjustment for leverage. Then the second step will be to use the capital asset pricing model to estimate the cost of equity capital. So here we have two inputs, the risk and the required return for risk. And lastly, as this is for equity holders, then we need an average for the whole company. The cost of equity would be the appropriate return discount rate for a full equity company. But if we have debt in the capital structure, then we need to average the cost of equity with the cost of debt or with other financing sources in the capital structure. So the last step will be to calculate the weighted average cost of capital, which is the cost for all the operations of the company. Okay, we are going to work here on an Excel spreadsheet. You can see the three steps. A, what is the risk of the project? B, what should be the minimum required return by stockholders using the capital asset pricing model, and C, what should be the discount rate for the project. Okay, let's start with the risk calculation. In this case, we don't have historical prices because the company is not listed in the market. Therefore, we're going to find similar companies in terms of the systematic risks, that is, the risks that cannot be diversified away. For example, interest rates, or that will affect many companies, not just one, or inflation, or political risk, or sector factors. And so we're going to find a group of companies. We have the lever beta of each company, which could be found by a regression of, well, this is the typical calculation of risk with a regression comparing the returns of each stock with the returns of the market. Beta will be the slope of the regression. And then we need the amount of debt in the capital structure. This is debt related to equity because there are two types of risk, business risk and financial risk. A levered firm has more risk than an unlevered firm. And as there's a tax shield, we need also the income tax rate. So what we are going to do is we're going to employ a comparable approach, and we need two formulas which are very simple. You can find them here. The first is the formula for the unlevered beta. This means that from starting from a levered beta, we can deduct part of the risk, which is the financial risk, and isolate the business risk. That's what the unlevered beta means. For example, in this case, these are waste related companies That would be the risk of the activity. But then we have another calculation, which is the levered one. Once we have, the first step will be to reduce all these levered betas, transforming them in unlevered ones. And then we reverse the procedure, because if we average all these betas, what we have is the risk of the industry, only the business risk, not the financial risk. Therefore, once we have this number, we need to relever, introducing the capital structure of the company we are trying to evaluate. And so we have a lever beta for this company. Okay, let's do it. First, again, we have the lever betas for all the companies, the debt to equity ratio, and the income tax rate. So here I'm going to introduce the first formula, which is the unlevered beta for each company. I'm going to obtain, of course, a smaller number, unless the company is full equity, in which case both will be the same. Okay, I will start with the levered beta divided by 1 plus 1 minus the tax rate times the debt to equity ratio. I repeat, the levered beta divided by 1 plus 1 minus the income tax rate times the debt to equity ratio here. I should always obtain a smaller number, in this case 0.97. So I copy for every company. You can see all the numbers in the column at the right are smaller than the numbers in the column at the left. So now we can average. Okay, 0.77 is the business risk of this activity. So what we have here is, suppose I have an investment project or startup, which is, of course, is not traded in the market. What I can find here is approximately the risk of the activity I'm going to get into. So this methodology, well, it's not perfect. It has some, well, it's not completely accurate, of course, but it gives us an idea, especially for projects where we're not going to have historical prices. Or for countries, as for example Guatemala, where there's no stock market. So we won't have the historical returns, not for the project and not for the market, which are the numbers we need to calculate beta. So here we have the risk of the activity. This beta will be applicable to a full equity company. But the company we are analyzing here, or the project we are analyzing here, is not full equity. It has a 50-50 capital structure, something like this. So debt to equity is 50-50. Debt to equity is 1. So it's a lever firm. It is a lever firm. We need to increase this number using the second formula. Notice that here we are dividing, and here we multiply. That is the difference. So we're going to increase this number, introducing the financial risk for a lever company. Again, we need the debt to equity and the income tax rate applicable to this project, the X project. Which one is the unlevered beta? Well, the industry that we have just calculated. And then here I'm going to introduce the second formula. Unlevered beta times 1 plus 1 minus the income tax rate times the debt to equity ratio. I'm going to do it here. Okay, 1.3, which means that this project is a little bit more risky than the average. Average would be 1. Okay, so we now have a beta for the project. Let's go to the second step. According to that level of risk, what we need to know now is what is the appropriate return to compensate for that risk. So point B, we'll use the capital asset pricing model. We could use also the arbitrage pricing theory, or there are other models. This is the most common and accepted in finance, but there are others. Some stockholders simply say, well, I would like 15%, for example. Warren Buffett does that. He just requires a minimum return, which is completely fair. This is a subjective input. Sometimes it's only an opportunity cost. For example, if a project is, if we're talking about a project where we are exploiting some land, the direct opportunity cost is to rent the land to someone else. So that's a minimum return that we should obtain in order for this project to be interesting financially. Therefore, we will estimate the minimum return for shareholders using this model, which is a very common way to do it. But there are other alternatives, and you should always have like an idea, a subjective idea of the minimum rate you would like to obtain to compensate the risk. Okay, so the inputs we need are the risk-free rate. In other words, at least we would like to be compensated for the time we are investing some money in this project, and at least it should return the same as a treasury bill, for example. But in addition to that, we would require a market risk premium. This is the return that usually the market yields above the risk-free rate. For example, we may say that typically the Standard & Poor's has a 10% return per year, more or less. It depends on how you calculate it or how many years you go back to estimate that, but it's more or less is that, 10% per year. So if a company has a beta of 1, then we're going to demand 1 time such 10%, right, over the risk-free. Assume risk-free, for example, would be 2%. So this is the risk premium, and risk premium is related to the risk. It's times the risk that we calculated. In this case, let's go to the numbers of this case. In this case, we have a 2% risk-free rate, a 12% expected return on the market. Therefore, this is subjective again. If we estimate that the market will, in the future, will produce 10% more than the risk-free rate of 2%. And this will be multiplied by 1.3, which is beta. For example, if we work with a beta of 1, then this will be 12%, simply. We demand the same as the market, 12%. but beta is higher. Therefore, we want 2% plus 1.3 times 10%. This is our calculation. Let's do it here. And then we have country risk, but I will add that later. Let's start with the capital asset pricing model. 2% plus beta times the risk premium. Okay, the result is 15%, which would be the cost of equity for a developed country. For example, in the US, for this company, we would use 15%. But notice that there's a country risk. For example, this could be for Guatemala or Argentina or Brazil. There's a country risk premium here of 300 basic points. Therefore, we could add this to the capital asset pricing model. Simply, we could add country risk premium simply by transforming the 300 basic points into an annual rate, which is only, you need to divide by 10,000. And then you have, for example, in this case, 300 basic points would be a 3% rate in US dollars per year. So the result should be 18%, right? After we add 3% more, we should end up in 80%. We can do it here. There, 18%. Okay, why are we adding a country risk premium? This was not in the original capital asset pricing model. It's a practitioner's approach, but it is true that in many emerging countries, we need to demand a higher return. And this is, again, is subjective, it's a practitioner's approach, but feel free to use it or disregard it. In the book, we mention a work that is known as the Goldman Sachs adjustment. You can read further about this addition to the original capital asset pricing model. Okay, now we know that the stockholders of this project should at least obtain 18% per year in US dollars for the project to be attractive. But this company, this would be the WACC or the discount rate for a full equity project. But again, in this project, the capital structure is 50-50. Therefore, we need to calculate an average of the cost of debt, which is 7% in this case, for example, the cost of loans and the cost of equity, which is 18%. We need to calculate the after-tax cost of debt, which is 7%. The after-tax cost of debt, which is 7% times 1 minus the income tax rate, right? So here the after-tax cost of debt is 4.8, which is of course smaller, is cheaper than the 7% cost of debt. This is due to the tax shield on debt. And then the cost of equity is simply 18%. Now we can calculate an average, which is weighted by the proportion of each financing source in the capital structure. Here we have 50% of the company financed by debt, which costs 4.8 per year, and the other 50% of the company is financed with equity that has a cost of 18%. Okay, 11.4, it is not a surprise that the weighted average cost of capital is somewhere in the middle of the other two costs. Of course, if it's an average, it could not be below 4.8 or above 18%. Therefore, 11.4 is the discount rate for this investment project, and it's also the weighted average cost of capital that we can use for the EVA calculation. Thank you very much. I'll see you in the next video. Bye bye.